In this video, we're going to be finding rational zeros. And to do that, we're going to be using the rational zero test. It's also referred to as the rational root test as well. So to find your possible rational zeros, you're going to take the factors of the constant term and divide it by the factors of the leading coefficient. So the factors of our constant term would be that end piece, and the factors of our leading coefficient are our front number up here. Except not the x to the third, just the front. So in this case, it's your invisible one. So to start this, we're going to find our factors of 1, which can only be 1 and 1. And then here, we're going to find our factors of our constant term, which in this case are 1 and 1, but also -1 and -1, right? But we don't have to write those, we can just put our 1s. So our possible rational zeros are going to be, we're set that up like a fraction, right? It's going to be plus or minus. And since they're all 1s, we really only need to worry about this one time. So we're going to have the 1 over the 1, which in this case is going to simplify to plus or minus 1. So in this one, it's pretty easy. We can just plug them in and see if it works. So we can try these. It's, like I said, it's pretty easy to plug these numbers in. So we're going to plug them into our polynomial and see what we get. Because if it works out, and it is in fact a 0, then that means that this number is going to be a 0, right? So what we want to know is, does this right here, does this equal 0? Okay, because we want it to be a rational 0. And sadly, when we work this out, we get a 3, which does not equal it. So 1 is not going to work, but maybe f of 1 equals. So let's try that one. So -1 cubed plus -1 plus 1. And so same thing, we're going to work that out. And we want to know, does it equal 0? So here we look at that, and we're going to get a -1, and a -1 is a -2 plus 1 is still a -1, which does not equal 0. So because neither of those worked, that tells us that there are no rational zeros here. So this wasn't too bad because you only had 2 numbers to plug in. But could you imagine if this number right here was a number like 24? There are tons of factors. That could be a lot of stuff to plug in. So then the question is, well, what shortcuts are there to help make it a little bit easier to know which numbers to possibly pick? And that answer is, you can use a graphing utility to help with calculations. You could graph the function. You could use the intermediate value theorem, or you could use the factor theorem and synthetic division. So let's go ahead and let's do another one that's a little bit more complicated. All right, so here we're going to find the rational zeros of f of x equals 2x to the third plus 3x squared minus 8x plus 3. So we're going to go ahead and we'll split this apart. So 2 and 1 are our factors here, and 3 and 1 are our factors here. So we're going to list our possible rational zeros. So if we list our possible rational zeros, when we set this up, remember it's plus or minus, we're going to take our 3, and it has to go with the 2 and with the 1. So we're going to have 3 over 2, and then we're going to have plus or minus the 3 over the 1. So now the 3 has been with both the 2 and the 1. And so now we're done with that one, and we can move over to the blue 1. So we're going to do our blue 1. So we're going to say plus or minus 1 over the green 2, and plus or minus the 1 over the green 1. And so now we can kind of simplify these, and we're going to get plus or minus 3 over 2, plus or minus 3, plus or minus 1/2, and plus or minus 1. We don't have any repeats, so that's good. So these are our possible choices. So that means that there are 8 different numbers we would have to plug in if we wanted to try all of those. And that kind of seems like a lot. And so we're going to go ahead and we're going to graph this so we can get a little bit better idea. So we're going to graph it. Let's pull up our graphing calculator. So here we have our function or polynomial plugged in, 2x to the third plus 3x squared minus 8x plus 3. And we can go ahead and we can hit graph. And we see that it looks like a -3 is a good possibility. And then maybe a +1 is a good possibility. And maybe even a 1/2. So -3, 1/2, and 1 would be good things to check. So then what we're going to do is we're going to do some synthetic division to see what that gets us. So we're going to go ahead and set that up. And let's go ahead and let's do that -3 first, since it was the first one we saw. And we're going to put in our leading coefficients of 2, 3, -8, and 3. Remember, I'm getting those from right here. And because every degree is taken care of, we don't need to have a 0 placeholder. All right, so let's go ahead and let's do this. So we're going to bring down our 2, and then we're going to multiply. So 2 times -3 is going to be -6. And then we'll add those and get a -3. And then -3 times 3 is a +9. And we'll add those and get a 1. And then 1 times -3 is -3. And we'll add these and get a 0. And the 0 is what we need, everybody, right? That's what we need. So this is saying that one of our zeros is x equals -3. Now, really quick, I want to point something out. So remember that this represented our x to the third spot, x squared, x, and our constant, right? And by doing the synthetic division, that makes it so that this is now down a degree. So x squared, x, constant remainder. So what we can do is we can actually rewrite this as a 2x squared minus 3x plus 1, and we can see if we can factor that. Because if we can factor this, it might be a little bit easier to do. But be warned, sometimes they don't all factor. And since when we looked at the graph, remember our graph, it kind of looked like one of the answers was a 1/2. It might be a little tricky to do that. But let's go ahead and give it a try. If I wanted to, though, I could just set up another synthetic division with the 2, 3, -8, and the 3. And I could try the +1 or the 1/2, and I could do that as well. But I'm going to try and factor this. So I'm going to set up my disco square. I'm going to put in the first thing in the first box. I'm going to take the last thing and put it in the last box. And then 2x squared times 1, so 2x squared. And I want to know what two numbers will multiply to 2x squared, but will add to that -3 that I need. And I think if I use a -2 and a -1, that will multiply to a +2 and add to -3. So I'm going to put those in my leftover boxes here. So -2x and a -x. And these have a 2x in common, and those don't have anything in common. So 1. And because my first thing was negative, my negative can come out. And then here, these have an x in common. And here, those don't have anything in common. But again, because my first thing is negative, I can take a negative out. And now I'm ready to write down my factors of x minus 1 and 2x minus 1. So x minus 1 times 2x minus 1 equals 0. And so I can do the zero product property here and get x equals 1 and x equals a 1/2. And now, using factoring, I was able to get my other two rational zeros. And so now I've got those values. And so I have an answer of x equals -3, x equals 1, and x equals 1/2 as zeros. So I could have rewritten this down and done synthetic division and tried the 1 and the 1/2 we got from the graph. But since it looked like I could factor my 2x squared minus 3x plus 1, I factored it instead. Either way would have been fine.